Hello everyone, welcome to this video. Today we are going to solve this particular equation. So this is an exponential equation. Let me read it out. 64 to the power x upon 48 to the power x plus 36 to the power x, and the numerator is 64 to the power x plus 27 to the power x, and it's equal to 193 by 44. Okay, the numbers are a bit peculiar here, but it's not at all peculiar. You will notice a lot of patterns here. For example, 64, 27 are your known numbers. These are perfect cubes. And so is 144. This is a perfect square. So there is some pattern going on there. Anyway, but that's not the point of the problem. What we want to look is on the left hand side. So let's start by simplifying it. First of all, we can write this as 4 to the power x whole cube, and this one as 3 to the power x whole cube. So that gives away a lot of information because once we're able to write it as cubes of something, so the only thing that was bothering us was the exponent with x, right? We cannot really work with exponents of x unless it is directly equal to something. But here we can, if we are able to, reorganize it in a certain way where we can handle the situation. Okay. So what is 48 to the power x? If you realize it is basically 16 into 3, which is 4 to the power x whole square into 3 to the power x, right? So you can simply write this as 4 to the power x whole square into 3 to the power x. Similarly, this can be written as 3 to the power x whole square into 4 to the power x equals to 193 upon 144. Now, for the sake of simplification, let a equals to 4 to the power x and b equals to 3 to the power x. So let this be done. And then our equation simplifies to a cube plus b cube divided by a square b plus ab squared equals to 193 upon 144. Now you know the formula for a cube plus b cube. So we'll apply the formula where it is factorized into two terms. The other formula is basically a plus b whole cube minus 3ab whole into a plus b. But let's apply this one, which is a plus b whole into a square minus ab plus b square. This you can get from the other formula as well, obviously, by taking a plus b common. And if you notice, there is also an AB common in the denominator, which will give you another factor A plus B, and you can basically cancel those terms off. Okay, let's keep the right hand side basically unchanged, and we have this equation. Now, if you cross multiply, what you get is this 144A squared minus 144AB plus 144B squared equals to 193A. At least our exponential equation is now reduced to a mere quadratic. So obviously there are mixed terms here and two variables, but we will not really be worried about that because this kind of equation where you have an two different variables with squares and their mixed product, that is xy and x square and y square, they can always be solved for x by y basically. You'll see why. So what we can do is this 144a square and bring this term to the left hand side. And I think 193 and 144, 200, and this is around 337 AD plus 144 b square equals to 0. So what I was talking about is this. If you divide by b square on both sides, since b is positive obviously, since b was I think 3 to the power x, what you get is this 144 will into a by b whole square minus 337 into a by b plus 144 equals to 0. And let's take another variable for the sake of simplification, that p equals to ab. And now our equation is basically 144 p square. Now it's a simple quadratic, right? 337p plus 144. Now it's a matter of only solving this one. You can use the Sridharacharya formula, but I would rather prefer because this is it's basically showing us what to do. So like 144p square minus, if you were to take, let's say, this product as 256 and 100, okay, yeah, that works. So this works. 256p minus 81p because of 16 and 9. Because I see a 12 and that is composed of 4s and 3s, and that is why 4s and 3s are also inside it. That is why this works. See that. This gives us 12p whole square minus, now 256 is there, and this can be written as 16p, right? So this can be written as 16 into 16p. And similarly, this can be written as 9 into 9p, and this can be written as 12 into 12. Now we'll try to do middle term here. So what is basically common from these two equations? Obviously, p is there. So you can take this 12 square and there is this 256. So out of 144 and 256, what do you get in common? That's the question. So do you get a 12 there? Yes, because 12 into 12 and from the other 12, you can get a 4, right? So this is basically 12 into 12. From that other 12, you can get, I think 4, which is 48. And that is basically 16 into 3, right? So this product is basically 16 into 9, like this, p squared minus 16 into 16p. That is what we have to realize here, and 9 into 9p. And similarly, this can also be written as 16 into 9. And to derive by 12 into 12 is 16 into 9, or to realize that this is the fact indeed, which is what we require, we simply have to just factor out both of them, which is what I did right now, right? Okay, so now take 16p common. We can clearly see what is common. This one comes as 9p minus 16, right? And from here, I think we only take 9 common, which again gives us 9p minus 16 equals to 0. And this will give us the final equation, 9p minus 16 whole into 16p minus 9 equals to 0. This gives us two values of p, namely 16 upon 9 and 9 upon 16. Okay. So that being said, we know p was a by b, and were a and b were 4 to the power x and 3 to the power x, 4 to the power x divided by 3 to the power x. If you combine exponents, since the exponents are same, we can combine the bases. This basically is 4 by 3 whole to the power x. So let us equate one by one. Case 1 should be 4 by 3 whole to the power x equals to 16 by 9, which is simply 4 by 3 whole squared. And this gives us x equals to 2. And the second case, which is 4 by 3 whole to the power x equals to 9 upon 16, which is just the reciprocal of the above expression, which is 4 by 3 whole to the power minus 2, right? This gives us x equals to minus 2. So the only two real solutions to the equations is x equals to minus 2 and 2. And that completes the problem. So if you did like the video, please check out the other video, which is of the similar kind. You will find them in the suggested video and on the cards above. And please do subscribe the channel for more of this content. Also, let me know in the comment section if you have any doubts. Thank you.